Welcome to Math TV with Professor V. I got a request to do a little bit of a more tricky, advanced, spicy integral of the day. So here you go. We have an indefinite integral of x plus 1 over 9x squared plus 6x plus 5 dx. So go ahead, pause the video if you want to try it on your own. Notice it's a rational function. So most people right away start thinking, oh, let me try partial fraction decomposition. But you'll probably notice after a few seconds that the denominator is prime. So that won't work. It doesn't factor. So what do we do in this scenario? We try to complete the square in the denominator, and then usually we do a trig sub. That's just how things go. So a little bit trickier of a denominator because we have that 9 coefficient on the x squared term. But I know I'm like really tempted. Here's 9x squared plus 6x. If I had plus 1, that would be a perfect square trinomial. So I'm going to steal 1 from 5, right? And then now I just have a 4 left over. That's the same exact thing. Do you know how 9x squared plus 6x plus 1 factors? Yes, it's 3x plus 1 quantity squared. And then the 4, I'll leave it as a 4 for now, but it's helpful that it's also a perfect square, 2 squared. Because like I said, we're going to do trig sub in a hot second. So here's our integral rewritten. Let's leave x plus 1 alone. And then I have 3x plus 1 squared plus 2 squared dx. And since I have 2 terms in the numerator, I think the best course of action is to split this into 2 integrals, and we'll tackle each one at a time. So x over 3x plus 1 squared plus 2 squared dx plus integral 1 over quantity 3x plus 1 squared plus 2 squared dx. Okay? So which shall we do first? I'll just do this one first because it's sitting right here. This second one is actually a little bit easier. Okay. So the difference between the two, and it's going to affect our integration technique choice. So pay attention. I have a variable in the numerator here. I do not here. So this is going to resemble tan inverse, okay? Because if I remember my antiderivatives, when I have 1 over x squared plus a squared dx, do you recall what that antiderivative is equal to? Why, yes, it's 1 over a tan inverse x over a plus c. So this is resembling this format here. I have a variable quantity squared, I have a constant squared, and just a constant in the numerator. This guy over here is different because we have the x up top, okay? So for this particular case, I'm going to use a trig sub because of the form of the denominator, and then we'll proceed from there. So how to do the trig sub? Normally, when you have the expression x squared plus a squared somewhere in your integral, you let x equal a tan theta. Can you see what a is for this particular denominator? Yeah, you could probably see, oh yeah, a is 2. However, instead of just x squared, I have this entire quantity 3x plus 1 squared. So that means we're going to let 3x plus 1, like that, keep it all together, one happy family, equal a, which is 2 tan theta. Okay, that's a little funky, but it should resonate if you just marinate on it for a minute or two. So this is the variable quantity squared. So that's what I'm going to let equal a tan theta, 2 tan theta. Okay, next thing, I'm going to differentiate both sides so I can rewrite the whole integral in terms of thetas. So derivative of the left-hand side, that would be 3 dx equals derivative of the right-hand side is 2 secant squared theta d theta. So if I get dx by itself, I have 2/3 secant squared theta d theta. All right, so going through, I've taken care of dx. I know how to write it in terms of theta. The denominator's taken care of, but what about this lonely little x up top? I want to rewrite it in terms of theta. So you're going to come back to where you let 3x plus 1 equal 2 tan theta, and you're going to solve for x. So 3x plus 1, well, let me move the 1 over. Let me get the ball rolling. So 3x equals 2 tan theta minus 1. So x equals 2/3 tan theta minus 1/3, like that. Or you could put it all over 3 if you want to leave it factored out. Okay, so we have, that's going to go in the numerator. You know what, let me leave it like this, 1/3, and then have 2 tan theta minus 1. That's x over, and then be careful here. So 3x plus 1, who's that? 3x plus 1 is 2 tan theta. If I'm squaring it, it's going to become 4 tan squared theta. Okay, 4 tan squared theta plus, there was a 4 there, times, and then remember dx I have right over here. Dx is 2/3 secant squared theta d theta. All right, let's see if we can clean up a wee bit because this thing looks out of control. Wild and out of control. Take the 1/3 out. Take the 2/3 out. I can also factor out a 4, and then I have tan squared theta plus 1. So let's see. 1/3 comes outside, 2/3 comes outside, 1/4, right? Because that 4 was in the denominator. And then I have 2 tan theta minus 1 secant squared theta d theta over, and then remember I took the 4 out now, so I just have tan squared theta plus 1. Ooh, here's the beauty of trig sub. What does tan squared theta plus 1 equal? That's secant squared theta. Ooh, fabulous, fabulous. So this will cancel. This is gone. And then can we clean up more in the front? Yes, this 2 can cancel with the 4. Now this is a 2. So I have sitting outside 1/18 integral 2 tan theta minus 1 d theta. How was that? Nice? Okay. Then we can go ahead, take our antiderivatives. This is going to be 1/18 times 2. Antiderivative of tan theta is natural log absolute value secant theta minus antiderivative of just lonely little 1 is going to be theta. And I'm going to put plus C1. Okay. Now remember we started in terms of x. So to get back there, I need to draw a triangle. Let me distribute the 1/18 first. So we have 1/9 natural log absolute value secant theta minus 1/18 theta plus C1. And how do you know how to draw the triangle? Come back, 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 back. You see right here where we let 3x plus 1 equal 2 tan theta. That's the key to drawing the triangle. So let me copy this little guy. Let's take him with us down below. Paste. Okay, what you need to do now is isolate the trig function. So I want to get tan theta by itself. So 3x plus 1 over 2 equals tan theta. Draw your triangle, okay? It doesn't need to be in any sort of proportion, just a right triangle. Tangent theta is ratio of the opposite side over the adjacent side. And then I can go ahead, figure out the missing side using the Pythagorean theorem. And notice 3x plus 1, oh, that was in the denominator of our integral originally. If I square it and add 2 squared, I'm going to get back 9x squared plus 6x plus 5. And that, my friends, is no coincidence. Okay, use the triangle now to go back and rewrite everything in terms of x. So we have 1/9 natural log absolute value. Secant theta is reciprocal of cosine theta, right? So it's going to be ratio of hypotenuse over adjacent side. So hypotenuse is square root of 9x squared plus 6x plus 5 over 2 minus 1/18. If you just have lonely little theta, what do? Again, come back here. Tan theta equals 3x plus 1 over 2. So theta all by itself must be tan inverse of 3x plus 1 over 2. Ooh, it's a little squished. It's a little squished. It's stressing me out because there's no room for plus C1. Scoot, scoot, plus C1. I'm going to do one more thing, okay? Are you ready? I'm going to use my log properties. And when I have a quotient in my argument, I can break it up and write it as two logarithms involving subtraction as follows. I could write this as 1/9 natural log square root 9x squared plus 6x plus 5 minus 1/9 ln of 2, the 1/9 distributes, and then I have all the rest of that stuff, minus 1/18 tan inverse 3x plus 1 over 2 plus C1. Okay, so that's integral 1. Don't worry, that was the harder one. So aren't you glad we did it first? Now, integral number 2. Do you remember what it was? Are you taking good notes? Here we go. I'll rewrite it for you. It was 1 over 3x plus 1 squared plus 4 dx. If you're pretty comfortable, you could probably anti-differentiate straight away. But if you want to do a u sub, that's fine. So in this case, you would just let u be 3x plus 1, then du is 3 dx, and then 1/3 du is dx. And then from here, you should be footloose and fancy free. So we have integral. Instead of dx, I have 1/3 du. So put the 1/3 outside, du over 3x plus 1, that's u. So now I'm going to have u squared plus, I'm going to write this as 2 squared, people, okay? And then you should recognize, this is going to be 1/3 times 1 over a, so 1 over 2, tan inverse of u over 2. Well, what was u? 3x plus 1 over 2, and I'm going to put plus C2. So simplifying, this is just 1/6 tan inverse 3x plus 1 over 2 plus C2. I told you this one was less painful, right? So if you wanted to like see a hint or a shortcut, how you could just jump straight there, right? I already noticed this is variable squared plus a squared. And if I did the u sub, I kind of just do it in my head. I notice I'm going to pick up a 1/3. So you could just jump right to here. Then you always have 1 over a, so you'd have 1/2 tan inverse of all of this stuff over 2, if you want to bypass the u sub. Okay, shall we put everybody together now? One big happy family. So let's fetch everybody from earlier. So all together. What do we have? Okay, so I had 1/9 natural log. I had radical 9x squared plus 6x plus 5. I'm going to write it as 9x squared plus 6x plus 5 to the 1/2 power, if you're okay. Minus 1/18 tan inverse of 3x plus 1 over 2 plus 1/6 tan inverse 3x plus 1 over 2. That's the new part from integral number 2. And then you're like, where are all the constants? I'm putting them at the end together. No, I didn't forget. So from the first integral, I had negative 1/9 natural log of 2. That's just a constant. Plus C1 plus C2, right? I'm just going to lump all those together. Even the negative 1/9 natural log of 2. That's just a constant. It doesn't involve variables. And I'm going to call all of that my new constant C, just so my final answer looks super clean. And then one other thing we can do, bring that 1/2 exponent in the front and multiply by it using log properties again. And then lo and behold, look, these guys are like terms. Can you believe it? I know. So negative 1/18 plus 1/6. 1/6 is 3/18. That's 2/18, which is 1/9. Okay, fab. So I think we're ready to put it all together. So moving the 1/2 in the front, now I have 1/18 natural log 9x squared plus 6x plus 5. Combining like terms, these two give me plus 1/9 tan inverse 3x plus 1 over 2 plus c, and I'm going to tell the people who c is because it's comprised of many things. I need to be precise, where c is c1 plus c2 minus, let's put that guy last, 1/9 natural log of 2. Boom, boom. So that concludes the integral of the day. I hope this was spicy enough for those of you who thought the other one was a little bit boring or whatnot, or just, you know, not exciting, not riveting. I get it. You want to be challenged. It's good stuff. I'm trying to check right now who commented for me to do it, and I'm browsing through, not able to find it. Okay, I hope you enjoyed the video. Oh, I don't know what the person's first name is, but their handle is Madness is Taking Over. So I hope you like this one. Yes, give it a thumbs up. Subscribe if you haven't already. Leave me a comment down below. I really do love reading them. Even just tell me what you're up to this weekend. What's your favorite video I've made? Subscribe if you haven't already. You can follow me on Instagram and TikTok, Math TV with Professor V. And if you need full-length video lectures, I got you. Everything's organized into playlists. So check them out. I think you'll be happy with the content that you find. And I'm always open to new ideas. So message me, email me. Love you all.